Hello girls, now we are in our 5th unit, Differential Calculus. Calculus is an important topic in mathematics. So, while dealing with change, we use calculus to calculate it. Okay, calculus means calculation. So, it is essentially concerned with the rate of change of dependent variable with respect to the independent variable. So, for dealing with a change, we use calculus. Okay. So, in this chapter, we are going to study about the functions, their graphs, limits, derivatives and differentiation technique also. So, our known concepts, constant, variable, and their types are also given. You kindly go through that. Okay. So, now in the interval, in the variable we have its types also, independent variable, dependent variable and everything. Okay. Now, we are coming to intervals. What is the interval? Interval on the number line, on the real number line we can mark intervals. So, it is the subset of the real number line. Interval is a subset of the real number line and it contains at least two numbers. So, open interval means the boundary points A and B are not included. So, if I write like this 1, 3, open interval 1, 3, then the points 1 and 3 are not included. This is the floor in the curved brackets, the open interval. Okay. So, here 1 and 3 is not included, but all the points between 1 and 3, all the points on the real number line that comes between 1 and 3 will come in the open interval. Similarly, we have closed interval. Closed interval means we use to denote closed interval as the square brackets. That means square braces minus 1, 1 means, okay. So, this denotes the closed interval. So, closed interval, here the point minus 1 and 1 are also included. So, the points between minus 1 and 1 and the points minus 1 and 1 are also included in this interval. So, open interval can be denoted by set of all x such that a less than x less than b. This is the open interval between a comma b, okay, a and b. So, the points between the points that lies between a and b will come in the interval. So, a less than x less than b. For closed interval, it is a less than or equal to x less than or equal to b. That means the points a and b are also included in this interval. Neighborhood of a point. For this, we will take a small number, a small real number, arbitrarily small real number epsilon, and it is also open interval a minus epsilon comma a plus epsilon, and it is called the epsilon neighborhood of the point. Okay, so, open braces a minus epsilon and a plus epsilon is called epsilon neighborhood. So, function. For two non-empty sets x and y be any two non-empty sets, we can define a function and we can write the function as f is a function from x to y. So, these are the types of function. Algebraic function. Algebraic function means they are algebraic expressions. They are known as algebraic function. So, it is polynomial function, rational function. Look, it is a polynomial function. This is a rational function and it is an irrational function. These are the types of algebraic function. Transcendental functions. So, non-algebraic functions are also known as transcendental functions. So, sine inverse, e power x, log x, they are all transcendental function. Even and odd function, it is an important concept. If f of minus x is equal to f of x, it is an even function. Minus vanishes here. If f of minus x is equal to minus into f of x, then we can call it as odd function. Sometimes few functions are neither even nor odd also. We can find functions like that. So, f of x is equal to cos x and it is an even function. We have studied it in trigonometry. Similarly, f of x is equal to sin x. It is odd function. Cos and secant are only even functions. Sin, tan, cosecant and cot are all odd functions. Constant function. Constant function f of x is equal to some constant. F of x is equal to k. It is known as a constant function. So, graph of a constant function y is equal to f of x is a straight line parallel to x axis. While we are graphing a constant function, it is a straight line that is parallel to x axis. Identity function. So, f of x is equal to x. If f of x is equal to x, then it is known as an identity function. So, modulus function. Graph of an identity function makes an angle of 45 degree with the positive direction of x axis, diagonal wise pogum. Modulus function. So, f of x is equal to mod x. We know modulus x and this modulus makes the negative number into positive. So, x where determinant it is this is the definition for modulus function. Modulus x is equal to set of all x if x is greater than or equal to 0, minus x if x is less than 0. Okay. If you give minus 3 inside the modulus value, you will get 3. This modulus function convert the negative number into a positive number, that is minus x, isn't it? Minus of minus 3. So, you will get 3. Okay. That is minus x. Another name of modulus function is absolute value function. Okay. Signum function. Modulus x by x. This is defined as signum function where x is not equal to 0 and 0 if x is equal to 0. Why? If 0 comes in the denominator, we couldn't find the value. It is an indefinite value, isn't it? So, determinant x by x, if x is not equal to 0 is the signum function. So, greatest integer function and least integer function. For greatest integer function, we denote it by x. Okay. So, the symbol along with x. We call it as floor function also. Okay. So, 2.5 with the symbol greatest integer function, 2.5 inside the greatest integer function gives 2. Minus 2.1 inside the greatest integer function is minus 3 because it gives the lower value. Floor function solvom. Okay. So, minus அப்படின்றதுனால minus 2. So, the least value is minus 3. 0.74 the least value is 0. Minus 0.3 the least value is minus 1. Next, least integer function. The symbol least for least integer function is the seal function. We will call this function as seal function also. Similarly, for the seal function, that is least integer function, inside 4.7 inside the least integer function will give its upper value. Okay. For greatest integer function, it will give lower value and the least integer function will give the upper value. The greatest integer kudukum. minus 7.2 it is minus 7, 0.75 it is 1. Rational function. A function is of the form f of x is equal to p of x by q of x is known as a rational function. Polynomial function. F of x, if f of x is a polynomial, then we call it as a polynomial function. Linear function. If it is of the form f of x is equal to ax plus b, then we will call it as linear function. Similarly, quadratic function. If it is a quadratic equation, we call it as a quadratic function. Exponential function. What is an exponential function? The function is of the form f of x is equal to a power x is called that exponential function. So, e power 2x, e power x square plus 1 and 2 power x are some examples of exponential function. Logarithmic function. So, f of x is equal to log x to the base a is called the logarithmic function. These are the properties, and we can graph the function. For any function, we can draw a graph also. First problem in exercise 5.1, determine whether the following functions are odd or even. So, few functions, some 5 functions are given, we have to find whether they are odd or even. What is odd? Instead of x, if you substitute minus x, and you get the same function, if you get f of x, then we call it an even function. That is, f of minus x is equal to f of x, then it is even function. F of minus x is equal to minus f of x. If you get minus f of x, then it is odd function. Minus observe ஆயிடுச்சுன்னா even function, minus vanish ஆயிடுச்சுன்னா even function, or else it is an odd function. Now, f of x is a power x minus 1 by a power x plus 1. So, f of minus x. I am going to substitute minus x in the place of x. A power minus x minus 1 divided by a power minus x plus 1, that is equal to a power minus x. So, I can write it as 1 by a power x minus 1 by 1 by a power x plus 1. Okay. We can take it as LCM, a power x as LCM. So, a power x in the numerator, it is 1 minus a power x. Similarly, here also a power x is LCM. So, 1 plus a power x. A power x in the denominator will get cancelled. So, I get 1 minus a power x divided by 1 plus a power x. Now, check the function. In the denominator, I have a power x plus 1. Here it is 1 plus a power x. No change. But in the numerator, it is a power x minus 1. But f of minus x is 1 minus a power x. So, I write it as minus of a power x minus 1 divided by a power x plus 1. This is our f of x, and so this is equal to minus f of x. Minus f of x. So, the given function in this problem is odd, because when you substitute minus x for x, you get the function as minus f of x. So, it is an odd function. Second problem, f is defined by f of x is equal to x cube minus kx square plus 2x, where x belongs to R. Find k if f is an odd function. If a function is to be odd, f of minus x is equal to minus f of x. So, this two should be equal. F of x is equal to x cube minus kx square plus 2x. Now, I find f of minus x. Instead of x, I have substituted minus x, and I have found this, that is minus x cube minus kx square minus 2x. Now, let us take this as 1. Now, I have found minus f of x. So, we have to change all the signs in f of x. So, that is minus x cube plus kx square minus 2x. So the condition is if f is odd, f of minus x is equal to minus f of x. F of minus x, what it is? Minus x cube minus kx square minus 2x should be equal to minus x cube plus kx square minus 2x by 1 and 2. Okay, these two should be equal. Now we can cancel the terms. Minus x cube will cancel, minus 2x will cancel. So we are left up with minus kx square equal to kx square. That implies when minus kx square we are going to the opposite side, it will be plus kx square. So 2kx square is equal to 0. That implies k is equal to 0. What we have to do? We have to find k, and we have find that k is equal to 0. Third one, f of x is equal to x cube minus 1 by x the whole cube. X cube minus 1 by x cube. Show that f of x plus f of 1 by x is equal to 0. So this is our function f of x. Now we have to find f of 1 by x also. So instead of x, you have to substitute 1 by x. So x cube, it can be replaced by 1 by x the whole cube minus 1 divided by 1 by x the whole cube. 1 by x the whole cube, that is 1 cube by x cube. 1 cube is 1. So 1 by x cube minus, this is also 1 by x cube, isn't it? 1 divided by 1 by x cube. So I can write it as 1 by x cube minus x cube. Because in the denominator we have a fraction, so with its reciprocal you can multiply. 1 by x cube, its reciprocal is x cube by 1, so x cube will go to the numerator. Now we have to f of x plus f of 1 by x. F of x is x cube minus 1 by x cube plus f of 1 by x is 1 by x cube minus x cube. So x cube and x cube will get cancelled. 1 by x cube minus 1 by x cube and 1 by x cube will get cancelled, and we get 0. That's what we have to prove. Fourth one, if f of x is equal to x plus 1 by x minus 1, then prove that f of x is equal to x. F of x, a function inside a function. F of x is equal to x plus 1 by x minus 1. So f of x, what we have to do? Instead of x in the function, we have to substitute the whole function. Instead of x, we have to substitute f of x. Okay, so f of x means instead of this x, we have to substitute the function. What is our function? X plus 1 by x minus 1. So instead of that function, instead of that x, here I substitute x plus 1 by x minus 1. x க்கு பதிலா இதை போட்டாச்சு, plus 1 divided by, instead of this x plus 1 by x minus 1 minus x. x க்கு பதிலா f of x substitute பண்ணுறோம். ஓகே, ஸோ இந்த எக்ஸுக்கு பதிலாக அந்த ஃபங்க்ஷனையே போட்டிருக்கோம். சிமிலர்லி இந்த எக்ஸுக்கு பதிலாக அந்த ஃபங்க்ஷனே போட்டாச்சு. ஓகே, now we can take it as LCM x minus 1. So here x plus 1 plus x minus 1. In the denominator also x minus 1 is the LCM. So x plus 1 minus x minus 1, that is equal to x plus 1 plus x minus 1. So 1 and 1 will get cancelled, 2x by x minus 1. Here x plus 1, here minus x plus 1 ஆகும். So x and minus x will get cancelled. So 2 divided by x minus 1. In both the terms, the denominator is same. So x minus 1 will get cancelled. 2 and 2 also will get cancelled, and you get x. So f of x is equal to x. That's what we have to prove. If f of x equal to e power x, g of x equal to log x to the base e, find f plus g of 1, fg of 1, 3f of 1, 5g of 1. So, f of x is e power x and g of x is log x to the base e. So, first to find f plus g of 1, we have to find f plus g of x. That is f of x plus g of x. That is e power x, f of x is e power x plus g of x is log x to the base e. Now, f plus g of 1 we have to find. That is equal to, instead of x you have to substitute 1, e power 1 plus log 1 to the base e. E power 1 is e. Log 1 is 0. Is 0, so it is e. Second, this is the first one. Okay. Now, second one, the product. So, f into g, that is fg of x is equal to f of x into g of x. That is equal to e power x into log x to the base e. So, fg of 1 is equal to e power 1 into log 1 to the base e. E power 1 is e, log 1 is 0. E into 0, that is 0. So, second one, fg of 1 is equal to 0. Third one, (3f) of x. 3f of x, a scalar multiplication. That is 3 into f of x. That is 3 into, what is our f? E power x. So, 3f of 1. That is 3 into e power 1. That is equal to 3e. Fourth one, 5g of x. 5g of x. Okay. That is equal to 5 into g of x. 5 into, what is our g of x? Log x to the base e. 5g of 1. That is equal to 5 into log 1 to the base e. Log 1 is 0. So, 5 into 0. That is equal to 0. 10th example. Draw the graph of the function f of x is equal to modulus x. You know, in the modulus, if we give negative values, it will turn into positive. So, y is equal to f of x, that is equal to mod x. And the definition is x if x greater than or equal to 0, minus x if x is less than 0. So, look at the table. We are going to give rational values. We are going to give few values for x and we have to find the value of y. So, for x, if I give minus 2, y is equal to 2 because modulus of minus 2 is equal to 2. Similarly, modulus of minus 1 is 1. 0 is 0, 1 is 1 and 2 is 2. So, these are the points we have got. Using this point minus 2, 2, minus 1, 1, 0, 0, 1, 1 and 2, 2, we are going to draw a graph. So, now we have plotted the points in the graph and this is the graphical representation of our function f of x is equal to mod x. 11th example, draw the graph of the function f of x is equal to x square minus 5. Now, let's take the function y is equal to f of x, that is x square minus 5. Now, we have to give suitable values for x. So, x square minus 5 is our function. So we are going to give some arbitrary values to x and we have to find the value of y. So minus 3, minus 2, minus 1, 0. If I take minus 3, x square minus 5 is our function. If I substitute minus 3 for x, what will happen? So minus 3 square, x square minus 5. Isn't it? Minus 3 square minus 5. Minus 3 square is 9. So 9 minus 5 and I get 4. So for minus 3 I get 4. Similarly, we have to substitute each and every values for x and you should get the value of y. Okay, now we are going to plot these points in a graph. And after plotting the points, you have to join the points and you have to draw a smooth curve. This thing we have studied even in 10th standard, but you used to draw this in the graph sheet. Now you have to draw this in the white paper. Seventh problem in exercise 5.1. Draw the graph of the following functions. The second subdivision, f of x is equal to x minus 2. F of x is equal to modulus x minus 2. Here also we are going to give some values for x, some positive values as well as some negative values for x, and we have to find the value of y. Okay, so no need to draw two tables. You can draw it in a single table. You can give some positive values and some negative values. For example, if I give x is equal to minus 3, what will happen? Determinant minus 3 minus 2, not determinant, modulus. Modulus minus 3 minus 2, that is equal to modulus minus 5. Modulus of minus 5 is equal to 5. So if I give minus 3, I get 5. Now I give x is equal to 3. So f of x is equal to modulus 3 minus 2. 3 minus 2 is 1. Modulus 1, and modulus 1 is equal to 1. So if I give 3, I get 1. Similarly, you can give some points for some values for x and you have to find the values of y, so that you will get coordinates. And then you can draw, you can mark all the points in the graph and you can draw a graph. This is the graph for y is equal to modulus x minus 2.